John Christy is a climate scientist at the University of Alabama in Huntsville, whose chief interests are satellite remote sensing of global climate and global climate change. He is best known, jointly with Roy Spencer, for the first successful development of a satellite temperature record. He received a BA in mathematics from California State University, Fresno in '73, an MS and PhD in atmospheric sciences from the University of Illinois at Urbana-Champaign in '84 and '87, respectively. His doctoral thesis was titled, hold on now, An Investigation of the General Circulation Associated with Extreme Anomalies in Hemispheric Mean Atmospheric Mass. And that's what he's going to talk about today. No, just kidding. He is the Distinguished Professor of Atmospheric Science and Director of the Earth Science Center at the University of Alabama. He was appointed Alabama State Climatologist in 2000 for his development of a global temperature data set for satellites. He was awarded NASA's Medal for Exceptional Scientific Achievement and the American Meteorological Society's Special Award. In 2002, Christy was elected Fellow of the American Meteorological Society. And I have to tell you as an aside, I told him just moments ago that I did the weather for 25 years on television, knowing one scintilla of what he knows, okay? And I would call him to say, what does that front mean? And he would tell me, and I would repeat it. So bear with me on this, John. Ladies and gentlemen, please welcome, and don't leave because he is also an ordained minister, and we have a final blessing after he leaves. The science facts of the global climate, and that too. John?
Thank you, Paul. It's a real pleasure to be here in Chautauqua County. My great-great-great-great-grandfather settled this area in 1811 and was one of the original settlers here. They traded with the Indians and so on, developed the area around Hanover Center and Silver Creek, Irving, around in there. And it's wonderful to see this crowd here, standing room. I'll try to keep it interesting. And for those 6 of you who are not over 70, I think I have some things here for you. But those of us who are north of 70, you know, reason I like audiences like this is usually our age group has had to work for a living through our lives, and sometime with muscled labor, you know, the kind of stuff that makes things work. And so you tend to be a little bit more, well, show me. When someone makes a claim about something, you're a bit more skeptical when you hear it, especially in the media today. In fact, dealing with claims about climate change, which is the topic here, and what I study, in this year is just extremely frustrating for someone like me, as it has been for over 25 years. I've been testifying for Congress. This is about 20 times now. And by the way, they don't invite you back to Congress if your story doesn't hold up. And so I keep coming back because what I present are real data, and therefore it's unrebuttable, basically. And so that's why this story has legs. It just doesn't have the kind of oomph in the political world. And I appreciate what your organization is doing in kind of swimming upstream against what goes on, especially here in the Northeast, when it regards to climate change. Here's just one example. This is just one of hundreds of examples I could show, but I was watching my local TV website, a weather website, and there was this chart. If you can see this chart here, it shows since 1970, the number of 95-degree days in Huntsville, Alabama has skyrocketed from 0 to 19 days or so a year. And then I noticed down here in the corner, Climate Central is the source of this information. If you listen to the Wall Street Journal fellow this morning, you know, what is your source? Are you giving anything trustworthy? Well, I happen to know that this is an environmental pressure group, so they're not going to give you real information. They're going to give you politically important information for their agenda. But I, as a state climatologist, I happen to know what the climate is like in Alabama. And I will just show you that when you graph the number of 95-degree days in Huntsville, Alabama from the time we started measurements in 1893, you see that the previous years to 1970 had many more days of 95 degrees than we're having now. In fact, the overall trend is downward in 95-degree days we have in Huntsville, Alabama. So, by the way, I sent the message to their on-air broadcasters and the station manager and so on. Not a peep, their story is still on the website. Okay, well, paraphrasing Lord Kelvin, all science is numbers. And he basically said, you cannot talk about science unless you measure something. And once you measure it, then you can talk about science. Not what you feel or think or anything. You have to measure something to be a scientist. But I will caution you what I have here in the red. The United Nations Intergovernmental Panel on Climate Change, and I was a lead author back in 2001 when they still had some kind of sense that we ought to have different views on the panel. Today, they're all of one side. But this is the UN panel. That today, evidence now includes model output and the judgment of experts. So when I was trained in science, and maybe many of you, the numbers, what Lord Kelvin said, that was what we started with science. But today, evidence is now not only numbers, but model output and expert judgment. Now, you think something could go wrong there? Well, we'll see. Anyway, about the Alabama thing, I wrote a practical guide to climate change in Alabama. I'm updating it right now. I should have it out at the end of the year. It's free. You can go to the state climatologist website of Alabama and download it. It's only about 43 pages. And I talk about national issues as well in climate change and this topic in general. So that's a good source of information, I think. So this talk has two main sections. One is I will show you what has been happening with the climate. So that's like a survey of the observations, what our data really show. And secondly, I will show what scientists have attempted in their ability, in their journey to explain why the climate has done what it's done. So we'll look at what the climate has done, and we'll try to look at some answers as to why it's doing what it's doing. So right now, you are flooded with stories of whether it's tornadoes, drought, floods, fires. Fires are great because of the visuals you get from them on the stories. And hurricanes, that we have these terrible things happening in the world, and it's pretty much our fault. That's kind of the storyline that we come, as if hurricanes and fires and tornadoes and so on had never happened before. Well, let's start with hurricanes. 2020 was a year record-shattering, right? In fact, here's some headlines here. The CBS Evening News, record-shattering 2020. Breaks all-time record. To me, when you break an all-time record, it means you have this long series of information, and the latest one is higher than all the rest. That's what I would think of about that. Breaks all records is The Guardian. By the way, The Guardian is the easiest target for people like me because they exaggerate and explode truth like crazy every other page. What did Lord Kelvin say? All science is numbers. If we go back and look at 2020 hurricane season, you will see this is the accumulated cyclone energy for that year. This is a measure not only of how many hurricanes, but how fast they were going and how long they lasted. So it's a real good measure of how much energy was in hurricanes. You see that in 2020, it was above the red average here, but 1933 was another 35% higher. So was 2020 record-shattering? No. Now, let's go to the North Pacific. The North Pacific was just barely above half of average. By the way, a lot more hurricanes in the North Pacific. When you get down to the global total over here, 2020 did not even make it to the average. It was not a record-breaking season in any way, shape, or form, yet that's the story we were all told night after night as these hurricanes occurred. In fact, let's look at a time series from 1979 to today through 2022. And this is 2020, the global cyclone energy from hurricanes. It's almost at the lowest level ever. And yet somehow that story has made it to us that 2020 was terrible, caused by humans and so on. Last year was almost the record lowest in terms of energy. Interestingly, the highest one, 1992, was the coldest year in the northern hemispheric summer of this time series. 1992. Pinatubo had gone off in 91. It shaded the planet and cooled it off. And so we had the most hurricane energy in the coldest year. What about tornadoes? If you look at the tornado history for the United States, we see that in the first half of this record that starts in 1954, we averaged 54 big tornadoes a year in the country. Now, the last half of the record, we see 34. That's a significant drop in tornado numbers in our country. Now, I'm a climatologist. I like to look at the longest record possible. This is the longest record we have that's possible. I would not be surprised if this turned up again. I mean, that's the way the climate does when you look at the long records. It's up, it's down, it's up, it's down. And why is a tough question to answer. Because if we know why, scientists, if you know why, you can predict it. Have you ever seen anyone predict accurately how many tornadoes we're going to have? I haven't, and I'm in that business. Droughts and floods. Since 1895 in the United States, lots of ups and downs. Some years are very dry, some very wet, but there is no trend at all in droughts and floods in the United States of America. What about globally? Well, here is a global metric of drought in 3 different categories here. This red is the worst drought. And what we find is that it's pretty level, and then all of a sudden something happened in 1981. Well, we had a new satellite launch called NOAA 7, and it has an AVHRR instrument that's able to detect very well droughts around the world. So all of a sudden we had a little spike up, but then it's been flat since. So in the satellite era, we've had no change at all in global droughts. What about heat waves? This is the United States. The United States as a whole, we're starting in the decade, this is 100 years, so it's 10 decades. And it's a way to measure how many heat wave days there were. So this is a period of at least 7 days that were very much above average. And so that would be a definition of heat wave. And what we see is that for the United States as a whole, this gray bar, the worst point was in 1930s when we had many, many heat wave days. And you remember 1936 was the big year on that one. But presently, it's about nothing. Now, let's look regionally around the country. And what we see is here in the Pacific Northwest and the Southwest, California, Nevada, and then Oregon, Washington, and Idaho, they've had, for this 100-year period, their record number of heat wave days this past decade. And there have been stories in the West, if you read the newspaper, it's all humans' fault. I have not seen a single story tell me that the Ohio Valley and the upper Midwest had their all-time lowest heat wave days, that we were responsible for that. So a scientist would look at the numbers here and say, heat waves come and go, but over the last 100 years, there has not been any change at all in heat waves. NOAA even understands this, but don't go to their website because they will hide it in various places. What about specifically, this is year by year. The red is for the United States as a whole. This is how many days of record high temperatures occurred. How many days, in what year did a record high temperature occur for a particular station in the summertime? And you see in the red, the biggest numbers are back there in the 30s again. But I also have up here what happened in the upper Midwest. Yes, Illinois, Iowa, Minnesota, and so on. And we see that, the 30s just dwarf anything. 88 was pretty bad there, but nothing really since. I mentioned those states because that's where a lot of corn, grain, and our agriculture economy depends. Well, as you may know, in Washington, Oregon, in 2021, there was a massive heat wave. I mean, it was colossal. It got hot. Records were broken by 5, 7, 6 degrees, 7, 8 degrees or more, all-time records. And when you look at the all-time records in the Pacific Northwest states, you see that virtually, more than half occurred for all those stations. More than half of those stations hit their all-time record in that. And so this outfit called World Weather Attribution says, that could not have happened unless humans had fiddled with the climate. That was their story, and they were sticking to it, by the way. Now, scientists would ask some other questions like, well, let's go to 1936 and see how many records were broken in the Midwest, and could that have happened because of human effects? No. That's how Mother Nature works with climate. It is up and down and can throw you a curve. When you're talking about a system that has two turbulent fluids, the ocean and the atmosphere, they're chaotic, they're nonlinear, they're turbulent. It can create an infinite variety of weather patterns that make the Pacific Northwest get real hot this year and not the next. So here's just a map to show you what it was like in 2021 for that heat wave and then 1936 for this heat wave. This is natural. That's supposed to be caused by us. A scientist would look at that and say, I can disprove that because of just these two pictures right here. So, well, what about, where are we going now? Fires. Oh, yeah, fires. State's worse, the Guardian said, for California. 4 million acres burned, record torched, and so on. Like I said, fires are wonderful for the news media because you have the great video to go along with it and things burning up, blight, and disaster, and so on. Lord Kelvin said, all science is numbers. Here are the last 400 years of wildfires in North America. Done by tree ring cores, basically. I had a graduate student do one of these studies once, and we drilled in to find out what years were fires. And so this has been done all over the North American continent. And we see that from 1600 to about 1850 or so, fires burned a lot. A tremendous amount of fires. If you think about it, back then when a fire was started by lightning or Native Americans or whatever, who put it out? Nobody. They didn't have any air tankers going over or hotshot crews, whatnot. They burned until fall, until fall, and that is why there was so much burned. And then the Europeans settled North America. And Europeans, Europeans have stuff, and they don't want their stuff to burn up. So Europeans put out fires. And you can see, they got pretty good at it. And so all you see in any kind of fire story today is what is the effect of human management? Clearly, it's the #1 factor in fire incidents today. I happen to still own a little piece of land in the foothills of Fresno County, California, where I was born and raised. It's a tinderbox there, and I haven't built anything on it because I haven't figured out how to build something that doesn't burn. But I want to show this so you can see how dry and it's just combustible like that. Before Spanish settlement, a great study by Stevens et al., 2007, pointed out that the average number of acres burned in California was about 8.5 million per year. 8.5 million acres burned per year on average in California prior to European settlement. The 2020 California acreage burned was under 4.5 million. So that record-shattering year in 2020 was about half of the average prior to European settlement. And so you see here that, what would Lord Kelvin say? All science is numbers. Let's look at the numbers to see what your claim can it stand any kind of cross-examination or test. In fact, I wrote about this a little bit in the book I called, Is It Getting Hotter in Fresno or Not? If someone buys it here, I might get into double figures on my book selling number, so. It didn't make any kind of chart, believe me. But I talk about how to build a climate data set for Fresno County, California, and the areas around it, but going through all the general details that you have to go through. And I had to enter with this hand over 100,000 observations from paper forms because they had not been digitized before. So it's the most complete temperature record of that area in the world. And it tells about why I like the weather. I go into that as well. I'm climbing up to my roof because I had a rain gauge on top of my evaporative air cooler in our home. I could see the Sierras out, especially at night. It was just beautiful. Anyway, I was a real weather nerd, believe me. What about fires? Let's count how much acreage has been burned since 1900. It is going down because everybody else in the world does not want their stuff to burn up. And here it is, by decade, the same thing is occurring. Fires are going down. Snowfall, guess what? It still snows. The amount of snowfall that has fallen on the northern hemisphere goes up and down, but there is no trend at all. The trend is 0.00 since satellites started measuring it back in the 60s. Has that affected grain production? No. And the main thing here is people are just getting smarter and smarter about how to grow grain, and so the world stockpiles are growing. What is really interesting is this chart that shows grain production continues to climb, even as the world has warmed a little bit, but the amount of acreage planted has dropped because we're getting so much smarter, we don't need as much land to farm to get more and more calories for the average person in the world. This is interesting. How many people die from climate and weather events? It has gone from near 500,000 per year down to almost zero. I had 2022 on here. It's almost zero because we have figured out how not to be affected by the weather. One of the big parts of this is the fact we've had affordable energy to help build our things and protect us from the climate, which can be dangerous if you're not protected from it. But there's been a precipitous drop in the death rate and so on from any kind of climate and weather disasters. You wouldn't know that if you watched the news today, but that is the story. In fact, GDP is also, the losses per GDP is also going down. So, the weather that people really care about is not changing for the worse. There is no attributable net negative consequence to humankind from anthropogenic climate change. You look at all the metrics, you can't find anything bad that's happening for people. And I've shown you some of them right here because of whatever the climate has done. In fact, it can be shown that there are negative consequences for policies that try to deal with climate change. And I can tell you that if you increase the price of energy, you've all of a sudden made people poorer. And I might have a slide on that later. So from what has happened with the climate to why? And here's the problem. The theory of greenhouse warming requires detecting a tiny influence on a massive climate system. This climate system is huge. Right now, there are aerosols in the atmosphere from fires in Canada. They are having an effect on the radiative column of the atmosphere right now in this area. And it doesn't make the sky look very good either. But that's the way it always looked prior to European settlement. It was always smoky and hazy around here. Okay, so what we have here, I've only got 2 or 3 kind of technical-ish slides, and I'm just going to say simply on this. Here's the atmosphere up here, this blue thing. So you're looking up, and that's the atmosphere. I have here, it sends down 100 units. I'm going to change that into watts per meter squared. So if you look up at the atmosphere, it's sending down about 340 units of energy, watts per meter squared, coming down on you. 340 joules per second per meter squared. The sun, on average, sends down 160 watts per meter squared. So that's 500 watts per meter squared coming down to the surface. We're trying to measure what less than 2 watt difference is doing in that system. Less than 2 watts. That's the forcing that the enhanced greenhouse gas, the extra carbon dioxide we put in the atmosphere to progress human life and enhance human life, that's the thing. So take that, the weather is doing all this, 500 is the number of watts per meter squared, and we're trying to detect what does that extra 2 do. It does something. Carbon dioxide is a greenhouse gas. It can't not be a greenhouse gas, but the magnitude of what it can do is pretty small. That's why it's so hard. For example, if you think about the surface temperature of the planet, it gets warmed by this downward air, atmospheric radiation, and solar radiation. That's at 500 coming down. It gets cooled by these 500 going up. And so if they're in exact balance, the temperature never changes. The extra carbon dioxide is this much on that tug of war. And so you can see, well, these guys flex their muscles and they pull and they change all the time, and that little 2 is not going to do very much at all. And that's why it's so hard to detect. We have been trying to detect it too. We think we might have a few things we found. So how do we test the claim that the current global warming is significant and is caused almost entirely by extra greenhouse gases that human economies emit as they enhance their ability to flourish and thrive? Yeah, I might have more to say about that. Anyway, you've heard that, and I've read it in official reports. The warming of the last 50 years is almost entirely due to the extra emissions we have generated. To test that claim, we must locate a test metric that has robust and scientifically defensible characteristics, and Ross McKittrick and I did that in 2018 and 2020. In fact, this paper in 2020 turned out to be one of the top 10 downloaded papers from the American Geophysical Union. It wasn't covered in the press because it didn't have a story that was amenable to most of those outlets. But it turned out everybody else evidently liked it, and I said to Ross, I'll bet it's a bunch of lawyers, because we are getting so many calls from attorneys now because they are being sued by these pressure groups, all the time. They're really bankrolled well, by the way. It's a big mountain of cash these guys have to fight against. And so they utilize evidence that we actually produce. So here's the test we did. It turns out, if you look at the temperature of the air about 30 to 40,000 feet up around the tropical belt, that's the key metric. That's where greenhouse gases are supposed to have their biggest punch. And so that's where you want to go to test it, is where the signal is biggest and the noise is smallest. So this right here is a cross-section of the atmosphere. South pole left, North pole here. This is stratosphere up here, the surface. So this is the vertical cross-section of the atmosphere. And this is a climate model result that shows that at that region to 30 to 40,000 feet in the tropics, it should be really hot. And this should have already happened. In other words, this is what the model said should have happened between 1979, I think here it's 2018 or 19. Anyway, 2018. So that again is our test metric that we're going to look at. So that claim is that significant warming should already have occurred in the tropical atmosphere as a signal of climate change, which is this CO2. All science is numbers. Here are the numbers from the 39 official, very expensive. Each one of these costs tens of millions of dollars per year to run. And we see here the trend is around 0.42 on average of all these models, and that's called the consensus. In other words, all the different models from all the different countries come up with these numbers of how high the trend is for those 45 years in that region. And you can see the different models. It turns out, for some reason, that the English-speaking world produces the hottest models. You think about that, but you see the Australian ones down there, Canadian ones there, UK Met Office, American ones here. They tend to be a little bit hotter. And this is the real world, 2.5 times less. Now, as a scientist, it's the kind of thing we were taught how to do. You make a claim, that's a hypothesis. We're going to test that claim with data not used to build the model. You got to have that separate. And sure enough, we can say, and that's what these papers said, was we have demonstrated, we have invalidated climate model output. That's the simplest thing you can say, and it's the honest thing you can say. In fact, this is a spaghetti chart showing what the real world did versus what the models did. There's something else to see here too. Notice that the models have these very wide swings in temperature. The real world doesn't have those. The real world has what we call negative feedbacks, so that when you get a little bit away from the trend line, something happens to bring it back. It's a damping mechanism that keeps you on a steady track. But in the climate models, they don't have those negative feedbacks as well formulated, And so you get these wild swings. And if you add a little extra forcing each year, those wild swings will take it up higher and higher as you go on. And so, you know, to people like me, this is real good evidence that you need to go back to the drawing board in some of the very basic formulations of these climate models that are used for policy today. You are paying more for energy today because of what this says up here, not what this says right here. Not just, we can leave the big tropospheric signal up there. Let's go to the Midwest 12-state corn-growing region. My colleague, Dr. Roy Spencer, did this chart. You can see that the observations for the last 50 years show a little bit of warming in the upper Midwest, in the Midwest. These are the 36 climate models he was able to get a hold of. They are in error by 50 to 700%. Now, I don't know if you ever do any engineering and so on. I'm sure there's some here. When you design a bridge and you say, well, you know, I'm within 100% of the error when it might break or when that airplane wing might snap, I'm within 100% error. You never get anywhere. Yet the financial, the economic impact of the decisions made on those climate models that have this kind of error are going on right now. Here's part of the problem in terms of the science, the why. When a column of atmosphere warms up a degree, we found out from climate models that they emit on average 1.4 watts out to space. They increase their emissions by 1.4 watts out to space. When the real world warms up a column of degree, it emits 2.4 watts per meter squared. You see that negative feedback? Warm up the atmosphere, it sheds the heat a lot faster. The climate model warms it up. It doesn't shed the heat, it keeps it trapped. And so that's why the temperature keeps rising and rising and rising in these climate models. In fact, this is remarkable too. These are a couple of scenarios of climate model projections out for the next 120 years, from 1980 to 2100. These are the observations. We are 1/3 of the way through a test period. If you are 1/3 of the way through your validation period and you are that far wrong, would you not step back and say, we better look at this and fix something, because something is really wrong? It's not just one model. As we showed on our paper in 2020, 100% of the models overwarm the atmosphere. But no, what I found is typically, not necessarily modelers, but people who use the models, when they see something like this, they just yell louder that their model is right. You know, it's the world that's wrong. So model projections have two major problems. They're giving too much forcing. By the way, I didn't go into this, but those models had more CO2 increases than actually have occurred. We haven't emitted that much, in other words. And the other thing, they're just too sensitive to that extra CO2. Now, I showed you that. It was pretty clear how they're warming too fast as a result. But someone will say, oh, no, the models are great because the surface temperature. Remember, I was showing you the upper, the tropospheric temperature in the tropics. The surface temperature is pretty close with the models. And this is an argument from one of the NASA guys. Well, in fact, they would say models are excellent tools because they match observations of surface temperature. Well, that's a real problematic statement because of this. First of all, the models are pre-tuned to the surface temperature. Okay? Notice they work on the models until it agrees with the surface temperature, pretty much. So what they're finding really is this, in blue. After the model was forced to agree with surface temperatures, it was found that the model agreed with the surface temperatures. Now, is that science to you? But that is exactly what. And I have a quote here from one of the famous models in Europe, how he says, we have tuned the model to match the surface temperature. I mean, they say that right in their papers. This is a complicated plot, isn't it? I'm going to show you how much we really don't know about the climate system, so I'm going to make this one look a little simpler. Okay. This is the target that climate models are shooting for, about a temperature rise over the last 150 years. That's how much the rise is, about a degree. And so they've broken that down to say, well, how much did Mother Nature contribute? And I have 3 of the models here, and this box represents a range with the others. The Hadley model from Europe, Norwegian model, and the Canadian model. All 3 models say, Mother Nature didn't have anything to do with climate. So how do ice ages happen? How do the 1930s happen? How do the 1820s happen? You know, that was Mother Nature. Yet they say, no, the models can't produce that. Then they say, okay, those aerosols you see out there right now, they cool the climate. But we really don't know how much. It could be up to, Hadley Center says, a whole degree. Some models say it's positive. It actually heats up the climate. In other words, if you take the median right there, the error is 100% on the response. How can anyone say the science is settled when on this particular critical component, how much do aerosols affect the climate, the error bar is 100% of the median? Let's go now, they say, oh, then there's a warming influence from carbon dioxide and the other greenhouse gases. And that has ranged from 1 to almost 2.5. Well, what is it? Is it 1? Is it 2.5? And the models there have a really good range, as you can see. That's the basic thing about how much does extra CO2 warm the atmosphere. Isn't that the big question? And here you see the science is far from settled on that particular component. In fact, in truth, we don't know from observations how to do this. We can't calculate that. So these are theoretical notions. And so when you add them together, I like the Hadley one. It's really the Goldilocks one. Too cold, too hot. When you add them together, you get just right, you know? And so they can say the Hadley Center model models the climate, agrees with the climate. When you look back and pull back the curtain, you see they're just tuning knobs to get the thing to fit at the end. That's not science. Here again is the tropical atmosphere. This is the surface, and this is stratosphere. This is just to show you, this is from one of the papers that was very popular. Models are way overwarming the stratosphere. It's warmer this way. Some of the models are just off the chart. They're just heating up the air way too much, and yet they are being used for policy, unfortunately. This just says bulk atmospheric temperatures that, like we produce with our satellite measurements and so on. That's the metric you want because it's the mass of the atmosphere. Excuse me for a second. I thank my wife, Sherry, for thinking about that ahead of time. Thank you, Sherry. Oh, this just says, not only is the bulk atmospheric a great metric, it's the bulk of the atmosphere, the heat's going to be, and the mass is. Our data set, the UAH one, University of Alabama in Huntsville. By the way, there was a slip up earlier. I heard University of Alabama. That's where they play football. We're University of Alabama in Huntsville. We used to play ice hockey. That was it. We play lacrosse now. But we're the Science and Technical University. Yeah. Okay. Anyway, that our satellite data set agrees best with independent data. And NOAA even came out this year with a paper that said, wow, their data set is right on. It's an excellent data set to tell us long-term temperature changes about how Roy Spencer and I put together all those different satellites and those radiance counts and everything to come up with a data set. Okay, so what have we learned? Models represent the level of our understanding or misunderstanding. Maybe I should say it represents our level of ignorance, right? In fact, I had a physics teacher in high school who said, you should always begin your statements about science with, at our present level of ignorance, we think we know. And when it comes to climate, that is exactly the right thing. You should be as humble as you can be because this is a turbulent system of two interacting fluids, and we don't know all the pieces of it, even today. So, where did I get off on that? Okay. So scientists have to explain the why of climate variations with greenhouse gases. as hypotheses, and that's all models are, do they succeed in describing the attributes of the physical climate so well as to determine policy? What have I showed you here today? Models fail to reproduce the past. Models have huge variability in the why components. Models fail to reproduce accurate energy flows. And models disagree with each other about the future. I mean, they're all over the place. Now, I lived in Africa, and I taught physics and chemistry at Nyeri Baptist High School in Nyeri, Kenya, 90 miles north of Nairobi, out in the rural areas. And so this is what we lived with. And this was the energy distribution system with the backs of women. They are, it was terrible. I would drive the soccer team by them in the van, and the amount of petrol I could hold in the cup of my hand could take all of them all the way home with all their 80 pounds of wood and potatoes on their backs. But this is the energy system. It's real bad because of the smoke that comes up, and that's the killer. The UN estimates 3.2 million killed. And so one of the most effective ways to create and ensure that all people, especially the poorest, live longer and better lives, i.e. a social justice issue, is to increase their availability to energy. That's the number one way you can do it. Or the most effective and immediate ways to create social injustice is to increase the cost of energy. That will hurt the poor the quickest and the most. And you can see that energy is being used by China and India. They're just going to town because their people don't like to be poor. We'll skip all stuff about solar energy and so on, but I have learned that when you have a story like mine and maybe like ABC, where you're swimming upstream, that people don't like your story. And this was right after the quote, so-called March for Science, when 7 rounds were fired into my office suite. And it was a Belgian 5.7 FN. It was a high-powered rifle to intimidate us about what we do. In my last slide, I want you to think about climate variability over the long period. This is a lake up in Fresno County, California, called Cliff Lake, and this is the current situation. So here's the lake level today, and there's the bed of the lake. There's a stump down about 5 meters below the surface. That stump, that tree, that type of tree, cannot grow unless the water level is a meter below the root system. Do a core, find out it grew between 1290 and 1340 AD. So that was dry ground. The climate was so hot and dry in the Sierra Nevada, by the way, these are found all the way across the Sierras, that forests grew on what are now lakes because it's cooler and wetter now than it was 800 years ago and 1,000 years ago. That's the power of climate variability of Mother Nature. And so until we understand that well enough, it's going to be hard to find out what that 2% or that 2 watts out of 500 is doing to the climate. So with that, I'm through. Thank you.
Is there any way you can do a truncated version of the solar? Because you have somebody in the audience who is anti.
The question was about solar and wind or something like that?
No, we have been going in this area, have had a real issue with the solar people coming in and taking over vast amounts of land, and the efficacy, long-term efficacy of solar.
This is how much stuff it takes to build a natural gas-fired power plant or something to get a unit of energy. This is how much solar it takes. So right there, you're 20 times the cost. Here's the point about solar. Photons from the sun are pretty weak. I mean, you and I can go out in the sun and just stand there and enjoy it. Now, do you think you can stand up in a gas-powered turbine in a power plant? You'd be burnt to a crisp. That energy is so diffuse, it takes a massive amount of material to catch it and squeeze it into enough to make enough electricity to come out of your plug. And that's why solar will never, ever compete in terms of cost and effectiveness. I mean, first of all, it's going to be gone for half a day because it's nighttime. But that's a quick story.
Okay, good. Sir, I'll hold it.
Oh, okay. You presented some interesting data. If I'm understanding correctly, according to your data, the climate has not changed significantly at all. I'm left puzzled. Are the polar ice caps shrinking or not? Are glaciers melting or not? Is the permafrost thawing or not?
Right.
Thank you.
Let's go to the glaciers, like Glacier National Park or Rocky Mountain or so on. Those glaciers began forming 3,100 years ago. There weren't any before that, okay? So they reached their peak about 1860, 1870, and now they're melting back. So a natural regression of that is typical. The North Polar ice cap is shrinking. It's not as small as it was, say, 2,000 years ago or so, but it is smaller than it was 300 years ago. Antarctica is still about the same. It is not falling. In fact, it has a slight upward trend in the ice around Antarctica. So that ice system is part of the natural variability. Some of that reduction could be due to the extra CO2, that extra energy, that 2 watts I talked about. Some of it could be that, but it has huge swings otherwise.
Okay. The good news is you don't have to believe in climate change. You don't have to think of that it's a hoax to want clean energy. I don't think anybody wants to heat their house with coal or oil or whale oil. Most people probably don't live near a refinery or a coal plant. Clean energy, fossil fuels kill people. They cause disease. There's well-known health effects, asthma, heart disease from fossil fuel. You're not going to stand in your garage with your car on because that exhaust will kill you. So right now, solar and wind are cheaper than most gas and coal.
No question, just a comment.
Okay, I would just say I can challenge every one of those statements with facts. Every one of those were false.
I'll hold it.
I was thoroughly shocked by your presentation. The most important data you did not show. There's data on the average temperature of the Earth over the last 100 years. The Earth is warming roughly 1 degree centigrade, 1.8 degrees Fahrenheit. But that's deceptive because the carbon dioxide in our Earth. Another number you did not mention. Before the Industrial Revolution, the atmospheric concentration of carbon dioxide was 280 parts per million. Does anyone know how much it is right now? Thank you, 415. What does that mean? That means the Earth is not only warming, it will continue to warm for thousands of years because that atmosphere, that carbon dioxide will...
This is not your senior thesis. What's the question?
The question is, how do you live with yourself? You are a fraud. You select data that is really not the important data. The average temperature of the Earth, the increased amount of carbon dioxide, that the Earth is not equilibrated to that carbon dioxide.
Thank you, sir. Comment.
I don't know what to say, except to say you're very emotional about the topic. I didn't have a single chart here that's been rebutted about what I said, so I'll stand on what I
You
showed.
just picked selective data.
So do the climate...
Well, okay, let's talk about selective data. It was warmer 10,000 years ago than it is today. The coldest century in the last 10,000 years ago was the 17th, 18th, and 19th centuries. We are coming out of the coldest set of centuries in the last 10,000 years. So the fact we are warming is natural. It has been warmer than it is today. That's also a fact. Yes, carbon dioxide has gone up from about 280 parts per million to about 420 today. Human lifespan has gone from about 38 years to 75. How many life years do you want to calculate as the value of that extra CO2? When you think of extra CO2 in the atmosphere, you've got to think, we didn't put it there because we're bad people. We put it there because it enhances and elongates our lives. Energy, and I lived in Africa, and I can tell you this, without energy, life is brutal and short, and I saw it firsthand. Energy has prospered us, has allowed us to live the lives that we like. None of us would be here without the types of energy I talked about that others have brought to our lives, which is terrific, I think.
I have a real question. So what are you anticipating about the catastrophic hot air that is going to come to Alabama in about 4 years when the FBI is moved down there?
Yes, it's a good point. In Huntsville, Alabama, we are having the huge expansion of the FBI facilities there, and I think we'll be able to handle it.
I get the sense that your work is hushed in academic circles. Was wondering if you've been challenged to a public debate, and have you accepted, or who would you love to debate in public on this subject?
Well, I have, and most often what happens is someone wants to set up a debate, and I will agree to it, and the other side does not show up. That's generally what happens. But I have debated. Michael Mann and I were opposite each other on congressional hearings. We have, both sides there, so you can see some of those and see how those went, and judge for yourself.
Hello. Hi. I am not a climatologist. I'm not a meteorologist. I'm not even a scientist. I do testify as an expert witness in various types of litigation. And so I can't assess what your answers would be to these questions, but I want to give some examples of the type of cross-examination that if I were a lawyer and knew something about the subject, I would want to see posed to you. For example,
How many questions do you have?
I've got few answers. I've got one answer, which is few.
That's good.
You said Lord Kelvin, according to Lord Kelvin, all science is numbers, but which ones? First, you cite accumulated cyclone energy when talking about cyclones, but then you shift to the number of tornadoes. You shift from the ACE figure to just a number. You didn't define dry and wet. You didn't define drought and flood. You gave a heat wave metric based on after 6 days. Why not 5? Why not 7? Why not 30? You get the idea. You cite climate deaths since 1920. You gave no mention of air conditioning, healthcare, advances in medical science over the last 100 years plus.
Let me stop you there. I did mention that. I did. Okay, go ahead.
No,
yeah, okay.
You get the idea.
Finally, and I'm getting close to the end here, so you don't need to panic. You cite your own studies and your colleagues' studies in support of your own conclusions, which is hardly independent. You criticized evidence from models at the beginning of this discussion. Then you cite models, and even more than that, simulations in support of your conclusions. Then you leave science entirely and argue politics and policy. You're silent on whoever funds your research. You're silent on whomever you may work for as private clients. Thank you.
Okay, well, let me answer the last one first.
Okay.
I receive no funding from any corporation, carbon-based or not. I am totally funded on the research stuff I do for federal and state grants. Okay? Do you understand that? I have no dog in the fight. Your government. Your government. Okay? I don't have any private. I said state and federal. All government. I receive a penny from a private corporation. Okay? What's that?
Okay.
No
Excuse
foundations.
me. You asked enough questions, sir. Let's get
Now,
some answers.
But let me say, on all those, I have been deposed, I have testified in federal court. All of those things are backed up by data. I can adjust the numbers however you want to say 5 days instead of 6 days or 7 days instead of 9. It doesn't change the picture at all. It's still the same. So what I showed you are numbers, and in fact, if you read the fine print on a lot of them, it shows you the source, where I got them. Nearly all of it's from the federal government, from NOAA. I mean, I'll defend that stuff. And I have in court, and no one has been able to rebut it.
Hi, this question has to do with the use of fraudulent science to bolster the claims of CO2 causality in the global warming. In 1990, NOAA released ice core data showing both medieval warming period and the Little Ice Age. This data corresponds to archaeological data of the period. Both of these events are inconvenient truths to the claim that CO2 is the primary factor in Earth temperature. In 1998, Michael Mann fabricated his hockey stick that erased both medieval warming and the Little Ice Age. So why do people still believe in the phony hockey stick?
I'll answer it this way. Scientists are people. People believe what they want to believe. Now think that through. Scientists are people, and people believe what they want to believe. I was a co-author with Michael Mann on the 2001 IPCC report. I saw that hockey stick thing. I confronted him with data that was different, that showed his hockey stick was not credible. He refused to include that in the IPCC so that you would have only his selected hockey stick as the result, and that was the one that was published and so much made about it. We've actually had congressional hearings on that, and the hockey stick has been demonstrated. In fact, there's a National Academy panel on it that shows that you can get that hockey stick from random numbers, the way Michael Mann did his mathematics. They were just wrong. Why do people continue to believe? Because it matches their view of the world. You know, the world is warming catastrophically. That hockey stick is able to confirm that idea.
I'll keep this out of the realm of cult religion. This question has to do with the legitimacy of the UN IPCC itself. That's the United Nations Panel on Climate Change, and its use of pseudoscience, which that's my words, but it's what I see. So researchers such as Roger Pilkey, Steve Koonin, and others have noted that the IPCC utilizes stealth advocacy to politically bias positions that are often directly contrary to the findings of the scientific community and within the IPCC itself, and of course you're involved in that. Dr. Judith Curry advises that in climate issues, truth-seeking takes a backseat to political advocacy, conjecture, et cetera, no hypothesis test, no true science in that. So my question is this, really, how do we as a civilization overcome the political corruption of climate science, and how do we uncancel the honest scientists that have been canceled? And if you don't believe me, look at Wikipedia.
Yeah, the UN is an organization that puts together the Intergovernmental Panel on Climate Change, and since 2007, those authors are pre-selected because of their views, and the governments approve them. So you're not going to get a nice, even distribution of scientists and how they work. They're ones that are pre-selected to give the right answer for the report. I was the last skeptic they ever had on the panel, but they had to have me because I was the only one who knew about satellite stuff, basically. So what can be done? You know, I've got this optimistic view that the truth wins out in the end, that you just keep hammering with the facts and the truth, sort of like what the Wall Street Journal fellow talked about this morning, and the trust will be built that what you were saying can be verified, it continues to be verified, that should be taken into account. Can that overcome the huge investment that certain groups have in the climate alarm? I mean, we're talking billions of dollars in trying to convince people of climate alarm. I'm talking about lawyers sitting in attorney general's offices paid for by these climate groups so that they would make legislation, green legislation, make solar look good or whatnot. They are planted in those kinds of offices. It goes far beyond that too. But you know, and plus there's another thing I'm really optimistic about, is just the American psyche. The American person is generally pretty skeptical, and as time goes on, they will just understand some things don't pass the smell test. We're not dying. fewer and fewer people are dying from climate-related stuff. Crops are flourishing. People are flourishing. You know, that all of these sad things that we are told about just are not happening. And that, I think, will continue to be the case. I'm optimistic about the future.
We're going to end with the man in the blue shirt. I'm sorry, but I'll hold it. I'll hold it. You talk.
So as I listened to your presentation, it looked like there was a great deal of data based on temperatures in the stratosphere, and then you briefly mentioned that some of the models were tuned to what was being measured at ground level. And I guess my question is why aren't those measurements, the real data, why aren't they in sync? Why is one level and one trending upward?
That's an excellent question. We've actually published on that. That if it's a system, if the climate system is well modeled, then this part of the system and that part of the system should be in agreement. And so this is one of the clues as to why the models are not doing well, is they're overheating the atmosphere up here while not overheating the surface. Now, that tells us that something in the atmosphere is what's going wrong. It's probably their precipitation processes, and they're not removing enough water vapor, which is a greenhouse gas. They're leaving it up there, and that's what warms up the atmosphere too much. But that's a very good question, that when you have a system and you're attempting to model it, you better get all the main components right. If you only get the one you tune to right, you don't have a model that reflects the system. But it's a good question. I don't fully know the answer, actually. How do you get to the answer? That's a long answer.
I'm just here to make the point that with all the effort the institution has put toward assuming that climate change is occurring and the resources of the institution that are going towards that, Advocates for Balance has today presented a forum for exchange of ideas and for real questions to be asked.
Thank you.
Thank you.
Having grown up on this lake before it was a glacier, and as a person that worked, I'm not an engineer like you, but I worked at Fluor and have friends in the nuclear. My SMRs, do you think there's a future? I'm just curious on your perspective on the new nuclear reactors are a whole lot different, and they seem to me like to be a good solution. And then second, and what book would you recommend to the people that want to learn more, maybe because they don't believe what you're saying? For me, Luke Warming at the Cato Institute years ago, I read that book, and it's helped a lot of my friends who were calling me deniers, and I'm like, I'm not a denier, I'm a lukewarmer. So I would ask, do you have any new books that you would recommend, and what do you think about the nuclear stuff?
For a general thing, that Alabama climate book has the general comments you're talking about in terms of the nuclear. I think there is a big opportunity there if our regulatory system will allow it to happen. We've only had, a couple of units built in the last 30 years. They're over there in Georgia, South Carolina, Vogel. And, if you really think carbon dioxide is bad, which is hard to imagine when you look at the actual numbers here, then nuclear would be the answer. It can provide, continuous, affordable energy. It has the highest safety record of any form of energy that we have. Yeah, I would. And small nuclear modular reactors would be kind of neat. You put them on a drain card, take them to a place, drop them in a hole, and you got 250 megawatts. That's pretty cool.
Before you part, I'd like to present something to our esteemed speaker, and then you can applaud. This is it.
Here we go. Why don't we just take it out? It's an appreciation from Advocates for Balance. For your time.
In our appreciation, we have given you this vase.
A vase.
That's because it costs more than $10.
Thank you very much.